Okay, in the earlier lecture, we were discussing about page replacement techniques or algorithms. So I have discussed first in, first out, if you remember. So what I will do is I will take another data set and I will repeat FIFO so that you can have better understanding. And moreover, we are going to observe one more important aspect or one more important property of first in, first out. So what is that? So consider the following reference string of a process. Means these are page numbers. Process want to refer page 1, then 2, then 3, then 4, then like that. So using FIFO replacement, we have to allot certain number of frames. So what are the frames that are allotted to the process? Let us take some frames. How many frames? We'll take 3 frames. So given 3 frames, how many page faults this reference string is going to cause? So let's draw the diagram here. Okay. So 3 frames, something like this. So I will take a row for first frame, second frame and third frame. So these are frames. Okay. So initially we are going to refer page 1. So therefore it is going to cause fault. We bring 1. In any of the empty frame we can load it. Next we refer 2 will cause a fault because 2 is not present. So one of the empty frame will load 2. Okay. 2 will also cause a fault. 3 will also cause a fault. So we bring 3 as well. So after that, which page do we refer? We refer page number 4. Page number 4 is not present. We have only 1, 2, 3. 4 is not present. So 4 will also cause a fault. But we don't have an empty frame to bring 4. So what are we going to do? We are going to apply page replacement. So point is, among 1, 2, 3, who is the first one to come? First in, first out. Who is the first one to come? Page 1 is the first one to come. So in place of page 1, I will load page 4. So remaining pages as it is, 2 and 3. Got it? So these are the pages now, 4 to 3. So remember, who is the first one among 4 to 3? 2 is the first one, then 3. Then latest we got 4. Got it? Next we refer 1. Do we have 1 available right now? No, we don't have. Will cause a fault. So who is the victim? Which page from 4 to 3 are we going to select to bring page number 1? So 2 is the first one. So in place of 2, I will load 1. Remaining pages as it is, 4, 3. I hope you are understanding. Alright, next we refer what? 2 will cause a fault. 2 is not present. So who is the victim? Remember, first we loaded 1, 2, 3. Now 1 and 2 are not there. So 3 is present. So therefore 1 we brought it just now, remember. So 3 is going to be victimized. So in place of 3 we will bring 2. 1 and 4 as it is. Okay. Next we refer 5 will cause a fault because 5 is not present. So who is the victim? Decide 1, 2. Then we brought 4. Among these two are the latest one to get. So in place of 4 we'll bring 5. Then 1 and 2 as it is. Remember, 1 is the first one, then 2, then 5, this order. Next 1 and 2 both are present, no page fault. Next we refer whom? 3. 3 is not present, will cause a fault. So who is the victim? 1 is the victim. So in place of 1 we bring 3, then 2 as it is, then 5 as it is. Then what will happen? 4 is going to cause a fault. So in place, who is going to victimize? Earlier 1, then next 2. So in place of 2 we'll bring 4, 3, 5. Okay. Then lastly we refer 5, no page fault. So this is how it executes. So with 3 frames, how many page faults has it caused? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 page faults. Okay. And yesterday, if you remember, I said that as we increase the number of frames, page fault rate also decreases. Remember, I will again show that graph which I have shown you. Small graph I will show. Earlier lecture you can see that big graph. Number of frames on x-axis, number of frames on x-axis, and here on y-axis we set page fault rate. So as I increase the number of frame, page fault rate we say should decrease. So with 3 frames I got 9 page faults. So what I am saying, suppose if I work out this problem now with 4 frames. So following this natural characteristic, with 4 frames the number of page faults should decrease. Am I right? It should become less than 9. So let us try to work out and see, with 4 frames will the number of page faults become less than 9 or will it be something different? Okay, so let's work out. I will take 4 frames. This 1, 2, 1, 2, 3, 4. 4 frames. I will take another ink now to distinguish so that you can have clarity of visualization. Okay, 4 frames. So what are these? These are frames. 1, 2, 3, 4. So let's start. I will rub off this. Okay. So again we can mark the dots. I will rub off this. Right. So slight changes for you. Okay. So this is 2. This is 2. This is 3. This line has been by mistake. Okay, doesn't matter, let the line be there. I will redraw my this lines so that I can have connectivity. Okay, so let's trace. Ready? So let's start. 4 frames. Meanwhile, I would suggest instead of me doing, you can also do it by taking a paper. So these are page numbers 1, 2, 3, 1, 2, 3, 4, 1, 2, 5, like that. So let's start. 1, 2, 3, 4. None of them are present. So directly I will write 1, 2, 3, 4. 4 page faults. I will load 1, 1, 2, 3, 4. 4 page faults. Look at that. Next, both 1, 2 are present. Both 1, 2 are present. No page faults. So then what we are going to refer? 5. Is it not? 5. So do we have 5? No, we don't have page fault. So who is the victim? Which is the first one to get it into this? So the first one to get into this is 5. So in place of 5, I will load, in place of 1, I will load 5. 5, 2, 3, 4. Very good. Now next, who is going to cause a fault? 1. 1 is not present. Look at this. This is my current scenario now. I don't have 1, right? I have 5, 2, 3, 4. So 1 is causing fault. Who is the victim? 2 is the victim. Because first we loaded 1, gone. 2, then 3, then 4. So 2 is the first one. So in place of 2, we are going to load 1. So 5, 3, 4. Got it? Okay. Next we refer to, do we have 2? No, I don't have 2. So 2 is also going to cause a fault. So who is going to be selected as the victim? 3. So in place of 3, we bring 2. So 1, 5, 4 as it is. I hope you are understanding. Next, 3 cause a fault because 3 is also not present. 3 is not present. So who is the victim? Earlier we removed 3. So 2. Now 4 is going to be victimized. So in place of 4, I am going to load 3. So 5, 1, 2, 3. This is my scenario. Then 4. 4 is not present, will cause a fault. So 4 will cause a fault. Who is the victim? See, these were the latest one. 5 has become old. So we are going to bring 4 in place of it. 1, 2, 3. Then last 5. Do we have 5? No, 5 we don't have. So 1 is the victim. Bring 5. 4, 5, 2, 3. So how many page faults? Calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 page faults. Look at this. Earlier how many page faults? 9. Now how many? 10. So what did we say? When I have 3 frames, number of page faults is 9. When I have 4 frames, the number of page faults should have been less than 9, but it is becoming more than 10, more than 9, it is becoming 10. This is going against the natural characteristic of this. As we increase the number of frames, the page fault rate should decrease, but it is not happening here. This is going against the natural characteristic. So anything that goes against the natural characteristic is known as anomaly. And this anomaly was observed by a person called Bellardi's anomaly. Anomaly means unusual, something going against the natural characteristic is called Bellardi anomaly. So this phenomena was observed by a person called Bellardi's anomaly. So what does Bellardi's anomaly say? I will write the definition, please follow. The first point, it says that generally with the increase in number of frames, page fault rate should decrease. But second point, sometimes with the increase in frames, with the increase in number of frames, page fault rate also increases sometimes. So what I'm trying to say, pay attention. So generally this is a general rule. As I increase number of frames, page fault rate should decrease. But what happens sometimes, not always. Like the first reference string which I have done earlier example, in my earlier lecture you can find, there was no Bellardi's anomaly. 3 frames has given 15 page fault, 4 frames has reduced the number of page fault to 10. Remember that last problem? But now for this new reference string today which I am working on, this reference string, with 3 frames number of page faults are 9 and with 4 frames it is becoming 10. So sometimes for few reference strings, sometimes, not always, with the increase in number of frames, page fault rate also increases. This anomaly is called Bellardi's anomaly of page replacement, and Bellardi's anomaly do not happen always for every reference string and for all replacement technique, but it happens only for FIFO. So remember this as a rule. FIFO replacement algorithm only suffers from Bellardi's anomaly. So no other algorithm suffers from Bellardi's anomaly, only FIFO replacement algorithm suffers from Bellardi's anomaly. I hope you got the point. Okay. So again I am telling, general rule is that as I increase the number of frames, page fault rate should decrease, but sometimes it happens that as we increase the number of frames, page fault rate also increases. This anomaly is called Bellardi's anomaly of page replacement, and only FIFO replacement suffers from Bellardi's anomaly. So this is the discussion with regard to FIFO replacement. End of it. So what I should do, what I advise you students, that you take these reference strings and try to practice it so that you gain confidence over it. Okay. Until that time you won't be able to learn this replacement. Repeatedly I am saying you will definitely get one problem on this for 5 marks. So if you get a problem and you become well comfortable, you can easily score marks in that. Okay. So please practice. So we'll look into next reference string, next replacement technique by using the same old reference string which we have seen in our earlier lecture. Okay. Right. All right. So let's continue with next replacement technique, which is called optimal replacement. So I take the same reference string which I took earlier, if you remember, for FIFO. Now I will work out with this. What is optimal replacement? Optimal means it is going to generate the minimum page fault. So this is going to generate minimum page fault. That's why optimal. So what does it say? It say like this. In the event of page fault, victimize, select that page as a victim, victimize that page which will not be used for longest duration of time in future references. That is what is called optimal replacement. So that means I will explain to you. Please pay attention. Okay, this is very important. I am repeatedly saying pay full attention, practice these problems, because I want my students to not miss these problems. Okay, victimize that page, select that page as a victim which will not be used for longest duration of time in future references. So let's trace, understand, so that you can follow. I will take 3 frames. I will work out for 3 frames as usual. So pay attention, understand. It's very simple and interesting. Okay, so let's see. So I will take, this is 1 frame, this second frame and third frame. 3 frames. So these are initial 3 frames. So first I refer 7 will cause 1 fault. We bring 7. You can load it into any of the frame. Next we refer 0 will cause a fault. We bring 0. Next we refer 1 will cause a fault. We bring 1. 3 page faults. No replacement needed. Okay. Now look at this. 2 is going to cause a fault. 2 is not present. So among 701 which are in memory, who should be selected as a victim to bring the faulted page 2? So for that we say, look into future references, and see which is occurring at the longest duration of time in the future. See, immediately after 2 we are going to refer 0. So 0 I should not remove. Like that you keep on seeing. We are referring 1. 0, then keep on referring 1 is occurring. Then 7. So 7 is at the end. Are you able to understand? Again I am telling. Not used for longest duration of time in future. So among 701 you have to see who is occurring at the end. So we are referring 0. 0 is there. Then we are referring 1. 1 is there. Then we are referring 7. 7 is at the last. So 7 is the victim. So in place of 7 I will bring 2. 0 1 as it is. Come on, work out this. Next, refer 0, no paid fault, 0 is present. Next, we refer whom? 3. 3 is going to cause a fault because 3 is not present. So, among 201, who should be victimized? So, who is occurring at the end? Come on, scan. 0 we are referring. Okay. Then, 2 also we are referring. 0, 2, 0, 2. 1 is at the end. So, therefore, in place of 1, we should bring 3. 0, 2. Come on, opportunity for you again to decide. Next, we refer 0, no paid fault, 0 is present. 4 is going to cause a fault. 4 is not present. So decide among 203 who in future is occurring at the end. 2, 3, 0 is at the end. So therefore in place of 0 we bring 4. 2, 3. Got it? Next. Again you can have opportunity. Don't worry. 2 is referred, no paid fault. 3 is referred, no paid fault. Next we refer 0. So decide among 2, 4, 3 who should be victimized. So look into future. 3 is referred, 2 is referred, 4 is not referred. Why should I hold 4? Remove 4. Bring 0. 2, 3 as it is. I hope you are understanding. Okay. Next 3, 2 both are present, no paid fault. Next 1 is referred, 1 will cause a fault. So decide 2, 0, 3 who should be victimized. 2, 0 are used. 3 is not used. Why should I hold 3? Remove 3. Bring 1 in place of it. So 0, 2. Okay. Then we refer 2, 0, 1, no paid fault, all are present. Next we refer 7 for the fault, 0, 1. 0, 1 are used, 2 is not used, so bring 7 in place of 2. Next, 0, 1 as it is. So 0, 1 are referred, they are present, no paid fault. So therefore 3 frames has given how many paid faults? Please calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9 paid faults. Got it? 9 paid faults have occurred with 3 frames. So what should happen with 4 frames? As an example or as an exercise, I want everybody to work out with 4 frames and prove that it will give you 8 paid faults. So this is an exercise for you. Okay, everybody should do it. 8 paid faults will happen with 4 frames using optimal replacement. So I hope you understood. Everybody is going to do this. All right, very good.